Hey, what's up? It's Theo from Hacking Academy here, and in this video we will learn the basics of how web applications work for hackers. There will not be any hacksoring in this video per se, but this is very important foundational knowledge for you to start learning about that later on. So let's get started. We're not going to go very deeply into how the different networking stuff works, because that's not really relevant for hacking web applications, but we want to know some of the basics to get an idea of how the internet works, which is kind of relevant. So the first protocol that we're concerned with is called the IP protocol, or the Internet Protocol. And what the Internet Protocol does is facilitates routing between IP addresses on the internet. And how this works, I can show you. We can have an IP address for example.com, for example, and we can just take this IP address, which is essentially a combination of 4 bytes, and that is values between 0 to 255, and we take the IP address and we run the traceroute command. And now we can see what starts to happen is that first I will send an IP packet to my home router, which is my home networking device, and then it will go to my internet service provider, which is ELISA, and then from there ELISA is going to look at the IP address, and based on the IP it will kind of know where to send the packet next, and then it will go to some other internet service provider, and maybe a third internet service provider, and eventually it's going to go to the server, to the web server that I intended it to the web server to whom that IP address belongs. So IP is essentially, it's like an envelope protocol. You will get an envelope, and then you will type that I want to send this envelope to this address, and I want the reply to my address. And that is how the IP protocol works. And one important thing to understand about IP addresses is that there are roughly 3 types of them. There is the loopback address, which is 127.0.0.1, which is pointing to your own device. It doesn't go anywhere, not even your home router. It is just pointing to your own device. And there is usually an alias defined for the 127.0.0.1 address called localhost. It's defined in your local hosts file on your computer, which is a file that maps IP addresses to names locally without using DNS, which we'll look soon. Then there are internal IP addresses. So if we look at the traceroute output from here, we can see that the first hop here was to my home router, which has the IP address 192.168.101, and this is an example of an internal IP address. So this is not routable from the internet, and there can be like a billion devices on the internet, and there probably are, that are using this exact same IP address, and they can all keep using the same IP address because it's an internal IP. So it's used within your home network or school network or your work network. It's basically any LAN, that is local area network, can use these internal or private IP addresses. And then there are the public IP addresses, such as this one here, which are routable from the internet. There is in theory only one recipient behind that IP address, and if you want to use such an IP, then you will have to reserve it. So now that we know how to send stuff to an IP address and get a reply back, we can almost start interacting with a web server already. And there is just one more little problem that we need to solve. So what if there are multiple network services running on the same host behind the IP address? So what if they're running like Telnet and SSH or something like that, other network services? How would we tell the server behind the IP address that we want to connect to this specific HTTP service, this web service? And how we do that is through the Transmission Control Protocol, or TCP protocol. So in TCP, we introduce a new component. We introduce the port number. So we used to have the IP address, and we still use the IP, but now we will also use a port number. And the default port number for the HTTP protocol, which is the protocol that facilitates the web, is port 80. The port numbers can range from 0 to 65535, but 80 is the default HTTP port, 443 is for HTTPS. But let's see, if we now connect to the example.com or this IP address, and we will add the port number 80, hit enter, and we will see that the connection succeeded. And now we can send an HTTP request here. So we can just type in here get/http11 hosts www.example.com, hit enter and hit enter, and now we send the HTTP request, and you will see that we got the reply back. Here it says example domain, and this domain is for use for la 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 la. And if you now go to the website with a browser, you will notice that it has exactly the same stuff. It has the same markup. If you go here and look at the page source, you will see that it is the same thing in here as we got here in our terminal with the raw TCP connection. So essentially the browser is going to do exactly the same thing that we did. We just made a raw TCP connection, so on port 80 for the web server's IP address, and the browser just did the exact same thing. So that is how browsers work. This also works the other way around. So if we want, we can be the web server. So we'll just listen on port 80, and when we'll go to the browser and we will connect 127.0.0.1 and hit enter, and we'll go back to the terminal, and we can see that we got an HTTP request from the browser. And then we can type a reply if we want. So we can do HTTP 11.200 OK, and we're going to content type text HTML and content length 14, and then we can do h1 hello h1, and then just end this message. And now if we go back to the browser, then we can see that the browser has successfully loaded our website. I think this is the geekiest possible way to create a web server. If somebody can think of a geekier way, then let me know in the comments. But how does the browser know what is the IP address of example.com? And that process is called DNS, or the domain name system, which is the process or the system through which domain names are translated to IP addresses. So how that works is that example.com people have at some point went to a domain register such as namecheap.com or godaddy.com or something like that, and then they have typed in here example.com, and then they put it to the shopping cart, and then they made some configuration changes, and from that point onwards the domain servers, DNS servers on the internet, have been resolving that name into the IP address that they want. So if we go here and we type in like nslookup and example.com, then we can see that the IP address is 93 and la 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 la, and we got the reply from the DNS server that is configured for my laptop here, which happens to be my home network device, which will then forward the request to the actual DNS server somewhere. Could be Google's DNS servers, for example. So that is how DNS works. So the next piece in the puzzle is the HTTP protocol. And this is the kind of foundation of the web. It's the most important protocol for you to learn when you're doing web application security testing, and also if you're doing web application development. So let's see how that works. Let's start creating an HTTP request. Let's name it HTTP.request, and here we can start the request. So the first component of an HTTP request is the HTTP verb. So it is, for example, it could be get. The get verb or get method is used for retrieving resources from the web server. So when you load a website or you click a link or something like that, it would be a get request. Then another option would be a post request. Post request is for when you are like submitting a form, for example. So when you are like saving your data on the profile page, or submitting a contact form, or basically editing anything, changing any data on the server, it is usually with a post request. Let's use get for our example here. So we'll type in get, and then we will have the path next. So the next component is the path. It can be just a slash. So when you like load the www.example.com in your browser and hit enter, then that would be, the path would be a slash then. But if it would be like their about page, then the path could be about. And maybe if it has some parameters, those would also go here. So if we have some like order.php id equals 25, that would also go here in this path. Now let's just leave it at slash for now. And the next is the HTTP version. Usually it is HTTP 1.1. It could also be HTTP 2 nowadays, but let's just keep it at 1.1. Not a very important component there. Then we have the headers. So the headers are key value pairs separated by a colon. So we could have something like at the foo, and the value of the foo header could be a bar. There are some headers that are like standard, and then you can put any custom headers that you want. One of the standard headers is the host header, so we can do host www.example.com. So the host header is used for virtual hosting mostly. So if you're hosting multiple websites behind the same IP address and port, then based on the host header you can discriminate whether you want to send the user to one website or another. Also, it is a good practice to check, even if you only have one web server, only one website on your web server, to check this host header, because then you will know that somebody who is visiting your website is not just some bot who is scrolling all the IP addresses for port 80, but it is somebody who actually typed that URL into the browser. Now this is already enough. We don't need any other headers here, but some of the standard headers that are usually quite relevant to like security stuff is the cookie header. So if we have cookies in the browser, then this cookie header is the way in which they are transmitted. So we can have something like session ID, for example, is 123, and some other cookie is ABC, something like that. Then we could have other things like if we would have a post request here, we could have the content length, which would tell the web server how many bytes are coming in the request body. Since we are just dealing with a single GET request, we don't actually have a body here, so we can just close this request now, and we see we have the request here, and now we can send it. So if we want, we can connect to the NC, and we'll connect to the www.example.com IP address and port 80, and then we will just throw this request file that we created into that connection, and we should be able to get this response here, example.domain. And we can also, if we want, we can just redirect the response also here, like to something like index.html, and here we have the HTTP response. And just like a request, the HTTP response consists of the headers and the body. But there are some subtle differences. For example, the first line here in the request, we started with the HTTP verb, and then we had the path, and then we had the version. And in the response, we have the version first, and then we have a status code and a status message. And the status code is implying the status of the request, like what happened with the request. Did it go well? Did some kind of error happen, and so on. Status code starting with 200 generally mean that everything went as expected. Starting with 300 means that we are now getting redirected somewhere, and 400 means that something went wrong with our request. So our request was somehow invalid. Maybe it was formatted badly, or maybe the page that we requested didn't actually exist on the server. I mean, you must be familiar with the 404 message. Maybe we were missing some kind of authentication credentials, so we got the unauthorized response, like 401 or 403. And when we have the status code 500, it means that something went wrong with the server, so something crashed unexpectedly. There was some kind of an error in their code. They didn't handle it gracefully, and now the server crashed, and we got a error 500 back. My favorite HTTP response code is definitely 418. I'm a teapot, which happens when the server refuses to brew coffee because it is permanently a teapot. So this is a legacy from an old April Fool's prank, which lives on today. So now let's just clear these headers here so that we will have a valid like HTML document here we can save. Now this is the source code for the example.com page that was returned in the HTTP body, and we can actually, if we want, we can just go to our browser and we can just open this file here like so, and we will see that the page loaded nicely. But what about HTTPS? How does the HTTPS protocol look like? compared to the HTTP protocol. Let me show you. So if we load this website with HTTPS, you can see it looks exactly the same, but now we have this login here and the connection is encrypted and so on. So if we now go to the terminal, I will show you how that works. Now instead of using Netcat to connect to the service, I will use OpenSSL, S-Client, and connect www.example.com port 443. So the one difference is that we are using port 443 instead of 80 as the TCP port, because that is the standard port of HTTPS. Now remember that these ports are not like written in stone, so there can be any service behind any port really, but these are just the standard ports. So we connect to the port 443 on this example.com using this OpenSSL S client, and we have now opened this connection. And now if we type in get/http 1.1 host www.example.com, hit enter and enter, we see the same exact reply. So that's how it works. HTTP is the protocol that we use in HTTP connections. HTTP is the protocol that we use in HTTPS connections. It is the same protocol. There is nothing different about it. It is just that the data that we now send in the TCP connection is encrypted with TLS. That's the only difference. I will not go very deeply into what TLS is, since that would require a video of its own, but TLS and SSL essentially they're the same thing. TLS stands for Transport Layer Security, SSL stands for Secure Sockets Layer, and they're the same protocol. It was just renamed from SSL to TLS at some point. And how this works is that we have something called a public key infrastructure, or PKI. It works so that somewhere in my browser security settings I have this certificate that my browser is configured to trust. Essentially it has a public key that corresponds to a private key that somebody somewhere on DigiCert has. And then once my browser is configured to trust DigiCert, then we will have example.com here, and example.com is going to present me with a certificate. And if we look at this certificate, we will see that it was issued by DigiCert, and my browser already trusts DigiCert, so that I will know that the site where I connected to has actually been given this certificate by DigiCert, so I can trust that this is the website that I intended to connect to. Okay, so HTML, or Hypertext Markup Language, is kind of the basis for websites. It is the document structure that defines what elements and colors and images and styles and content you see on the page. Let's now create an HTML document. So we'll name it index.html. Doesn't matter what you name it. Usually index.html is the website that is loaded when you load the root URL of a website. So we'll just put something like a doc type HTML, and this is just a good practice to define a doc type so that the browser will know that this is an HTML document. And then we'll start adding these tags. So we'll add an HTML tag meaning something that starts with a smaller than and ends with a larger than, and then this tag also needs to be closed, so we close it with a smaller than and a slash, and then the tag name and larger than. Now this is the tag, and inside this HTML tag we can now start to add other tags. Like for example, we can add a body tag, and within this body tag we can add something very basic, like maybe we will add a big heading. So we will add h1, which is the largest heading. And in this h1 we will say maybe hello world page, I don't know, h1, and we'll close it. And now we can open this file. We don't need a web server to serve this. We can just open the file in the browser directly. So we'll have the file path in here. We'll open the file and we can see this hello world page. Now some other stuff we can do on the page. We can add a paragraph here, for example, that has some la 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 text. And now if we add a head section in here, and in this head section we can add stuff like like styles and some metadata and stuff like that. So let's add a style, and the syntax for writing this style inside this style tag is called CSS, or cascading style sheets. And here we can say stuff like the paragraphs, all paragraphs on the page will have their color be set to red. And now if we just refresh the page, we will see that we have a red paragraph here. Now some other stuff we can do, we can write scripts. So we can have like a script here, and the script, when it executes, will show an alert box that says hello script world, something like that. And now if we refresh the page, then we load, then we see this hello script world in there. And now we can also load the scripts and any resources pretty much from external sources as well. So maybe instead of having this script here, we would just create a new file. We'll create something like a script.js, for example, and here we will put like alert hello from like external scripts. There, we'll save it, we will go back here, and now we will add a script tag, but this time we will give it the src attribute for the source from where to download it. This could be a full URL, we will just give it script.js because it's loaded right there from the same directory. Close the script tag, and now if we just go and refresh the page again, we should see that the script executes. If we take the developer tools here and just open this network tab, which is already open, and just refresh, we will see a separate HTTP request being made for this script in here. So the DOM, or the document object model, is the in-memory representation of the website in its current state. So when we open this page, the browser is going to parse, it's going to process this HTML that we created, and then it will create this DOM. So what we are seeing on the page is not the source code, it is the DOM, and the DOM we can also modify. So basically DOM is the list of elements on the page, or the element structure. For example, we can just modify the DOM here. We can change the text of this header tag, and now if we go to the view page source, we can see that the source is the same. The source hasn't been modified because it is only the DOM, the in-memory representation of the current HTML elements, that has been modified. And also, if we have some JavaScript code, the JavaScript code is executing in this DOM. So for example, if our header tag here had an ID, for example, ID if our header, then we could, in our JavaScript code, we can now access it. So we can do like document.getElement by ID, our header, and then we will see that it returns the object here. Then we can remove it. Boom, it's gone. So that is how the DOM works. A very simple way to run a web server is that if you have Python 3 installed, you can just type in Python 3-m http.server and hit enter, and it will start an HTTP server for you. You can give it a port also, so you give it port 80, and then it will start it on port 80, which is the default. Then we don't have to specify the port in here, we can just do it like so. If we did run it on port 8080, like I said, it doesn't matter what port you run your services on. You can do 1, 2, 3, 4, 5 like so, and then we are serving the web server on port 1, 2, 3, 4, 5. Now we just have to specify that here. So we have this host name or the IP, and then we type in colon 1, 2, 3, 4, 5, and then we can still connect to the server. Now we can kill the server, and we can create some simple index.html page here, HTML body h1 hello, h1 body close, HTML close, and that's ready. And now we go here and we just restart the server, and we go here, refresh, and we can see our page. Sometimes we don't want to create a static website, we might want to create a dynamic web application. So for this example, I will show you how to create one using Python and Flask library. So we can just start creating the app.py file, which is the py is the extension for Python, and we can need some import. So from the Flask library, we would import Flask and request, and then we would create the app. So we would do app equals Flask, yeah, and it requires this name here. And then we need some route. So let's create, for example, let's create some mathematical dynamic. Let's create an add function here. So we create app.route /add. And now whenever somebody calls that route, this function here, this our add function is going to be called. And in here, we would take maybe parameters called like the op1 equals int cast to a number basically, and we get the request.args.get and the op1, and the op2 would be the same, but instead we would just op2, and then the result or the sum of operands would be op1 plus op2, and then we would just return sum and the number here, this sum of operand, something like that. This would be a very basic web application that it takes two parameters, the first operand and the second operand. It will calculate what is the sum of those two, and then it will return that in the HTTP response. So let's just save this and hit Flask run, and it will run our application. No, it won't, because there is some error. Let's go see from Flask import Flask and request. Let's try again. Now it will, no, it still will not run it. Where did we go wrong? App.route. Quite so. Run again. Fantastic. It is running on port 5000, and now we will just open that in the browser. We'll type in HTTP 127.0.0.1, and the port was 5000 and slash, and the route was add. And now we will add the parameters. So the query string works so that we first put this question mark, and then we will put those parameters. So we will put op1 equals, let's say 3, and so ampersand op2 equals 7, for example. So the result should be 10, right? And yes, sum is 10. So we have successfully created a nice dynamic web application. Woohoo! So a very common requirement for web applications is to be able to render HTML documents based on some parameters. The parameters could come from the user input, like the request, or they could come from a database, for example. I have created a little application here that asks for the user's username, and then it will render that username in this HTML here. So let me show you how that works. We go here and refresh the page, type in something like Theo here and hit submit, and then we see it rendered on the page. We look at the page source, the username is right there. So this is a horrible way to construct HTML, and the reason is that we are just concatenating strings here. We have this string that we are concatenating with the username variable here, and then we are concatenating more text. And what happens is that if the username contains something that messes up this HTML document structure, then the username can insert evil things on the page. Like, for example, we can insert a picture of a cat here. If we just put this image tag here, so instead of the username, we are now seeing this cat picture here. If we look at the page source again, we can see that instead of having some text here, we actually have this HTML tag. We can also put a script here, like evil JavaScript running on the page, and that would just execute on the page. So this is not a very good way to create HTML. This is a little bit better. So now we are not just putting the string in here, we are first running it through this HTML.escape function, which essentially will HTTP entity encode the text before putting it on the page. And what entity encoding means is that it will take the characters that would mess up the HTML and then just change those to safe equivalents that will still render properly when you look at the page. So let me show you. We put in here Theo, works fine. We put in here script, and it will show as text on the page instead of modifying the HTML structure. We can verify this. Looking at the source code, we see that it has been HTTP entity encoded. The characters that would have been dangerous here have been replaced with safe equivalents. So now this is not vulnerable, but this is still not a very good way to construct HTML. You would have to remember to call this HTML.escape for every single parameter, which doesn't scale very well with large code bases, and also this isn't very nice, creating these strings with that have HTML tags in them. This is very, very ugly. So there is a proper way, and the proper way is to use a templating engine. So for example, I have used the Jinja templating engine here. It is just one for Python. So instead of having that HTML here as part of the code, we have it here in a separate index.html5 file, which has this username here as a parameter. And then in our app.py here, we are just taking the username, and then we are calling this render template function, giving it the index.html, and give it the parameter. The username is whatever the user inputted. And let me show you how this works. We have this page here, and again we type in Theo, works fine. We put scripts here, and they will get HTTP entity encoded. But this time we don't have to call any HTML.escape manually, but it is all handled automatically for us by Jinja. So that is the magic of templating engines. Of course, it is possible to use those wrong as well and still end up with such an HTML injection vulnerability, but it is much better than the previous two approaches. So one little problem with our application currently is that it doesn't persist the state. If we type the username here and hit submit, it gives the username Theo, but now if we just refresh the page, then the username is gone. So how do we keep the username there once the user has entered it? That is where cookies and session management come in. So I have changed the example a little bit again. Now we are requesting the username, and we have the same templates and everything. But now when we get the username, we are sending a cookie to the web browser that says that set the cookie username to the value of whatever the username was. And when the page loads again, we will try to get the username from the cookie named username and then render it on the page. So let's see how that works. We'll go here and we'll type something like Theo in here and hit submit. And then we can see here in the developer tools that we have now a cookie called username with the value Theo in here for this application. And if we just refresh this page, then we are still Theo. And if we want, we can just change this directly from the developer tools, changing the cookie to something like la 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 la, and refresh, and now we're la 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 la. If we look at the HTTP traffic a little bit, so what happened when we sent that post request with the username Theo, we will see that the response that we got had a set cookie header, and it had the value of username equals Theo. So that is how it works. That is how we got the cookie. And then when we send the next request here, our request contained the cookie header here, which had the username Theo. So the set cookie is how the web browser sets the cookie into the browser, and the cookie header is how the browser will then transmit that cookie back to the web server whenever it makes any requests there, which enables for the web server to persist data for the user's session. Of course, there is one little problem with our application, because anybody can just come here and say that they are Theo or they are Jack or whoever, and we don't have any authentication here. So let's look at that next. So we have now added a very primitive authentication and session management mechanism here. This is not what you would do in a real application, but it serves to prove a point. So here are some users. We have Bob here with the password let me in, and the Lisa with the password secret. And then we have a dictionary here with sessions. And then in our index function here, we now have a session ID that we try to get from the cookies, and then we have a username which we try to get from the sessions. The idea is that we ask for the username and the password, and then we check for this list. Is there a user with that name and that password? If there is, we generate a random ID that we then store here in these sessions, and we will map that ID to that username. And then when the user visits the page next time, the user is already logged in, and we will get the session ID from their cookies and get the username from the sessions. So that is how it's going to work. So let me show you. We'll go here to the app, refresh the page. Now we can put in something like a Theo and and we get invalid username or password because there were not any matches. But now if we use one of the valid users like Bob and let me in here, so we'll type in Bob and let me in and log in. Now we can see that we are logged in here. We can see that the username is Bob, and we have a new cookie here that says session ID equals, by the way, this cookie is from the last lab, we don't have to worry about that, but we have this session ID is this randomly generated value that we now on the server side in our application are mapping into the user. So this is on a very basic level how authentication and session management really works. Okay, so we've got some new features here. We can log in as Bob and let me in, and we can create some notes here, go to store, do this, do that, and then we can log out and we log in as Lisa as secret, and Lisa will have her own set of notes in here. And this is all facilitated with a database. So database is just some kind of a place for storing data. So there are many kinds of databases. We are using something called SQLite here, which is just a simple, lightweight SQL database that we can store here on disk. This is good for demos. I use it a lot. Then there are others that run as their own servers, for example, MySQL or MariaDB or Microsoft SQL Server or Postgres and so on. There are many different ones, but pretty much they all store data. So in here, our app.py looks a little bit different. We are importing some database stuff. I don't want you to worry about that. But here we are defining a table. The table name is to-dos, and it has 3 fields, an ID and a username and a note. So the idea is to create these notes or these to-dos in the database, and each of them will have their own ID, which will just be a number that is automatically incremented. And then there is the username, which is there to tell the web application which user this note belongs to. And then there is the note, which is the text. So string means text, integer means number. I think the most relevant part here is this new note, where we are now taking the parameter note from the form here. So in here we had this form with the note, and when we put like hello in here, the browser is going to send a post request. So if we just go to burp here and we look at the post request, we see that there's a request for a new note, and it has this note equals hello as the request body. So when our application receives that request, it is going to take the node parameter, then it makes a connection to the SQLite database, and it runs this SQL query. So it runs insert into to-dos, username note, values, username note, and then we fill in those values in here. This is fine. This is a reasonably safe way to construct SQL, because these are parameters that the library here, SQL Alchemy, is automatically going to escape. But of course, if we would just do something like this into values and then just like plus and the username and then like so, then we would have the same type of vulnerability as with the HTML injection previously, but we would have SQL injection, which would enable the attacker to just modify the SQL and usually take full control of the database and just steal all of the data. So we don't want that. We want to be careful with those. But anyway, we run this query that will insert it into the database, and then we redirect back to the front page. And on the front page, we have another query, which is now a select query. So insert query will insert stuff into the database. Select query will select stuff from the database. So we are selecting everything that is all columns from the table, from the to-dos table, where, and then we specify some rule here. So we don't want to show all of the to-dos to any user out there, but we want to have kind of authorization and access control. So we are only selecting the to-dos that belong to this user. So we take the username from the session identifier that we created previously, and then we select all the to-dos where username is, and then we fill in the username from the session. And then for all the returned rows, we just add to this nodes array here, and then we pass that nodes array to our template here, and in the template we just have this loop like for all of the nodes in the array, create this list element with that node in here, which is this. So that is approximately how databases work. Okay, that concludes the very basics of how web applications work for hackers. So now you know how session management work, and how cookies work, and how the HTTP protocol works, and how the IP and the TCP and DNS and the network stuff works. And now you are ready to start learning about hacking web applications. But I do recommend you dig even deeper into some of the topics in this video, and I will put some good links down there in the description for you. So enjoy the summer and happy hacking.